To verify the Ohm's law principle is our goal for this fourth lab experiment that we will be presenting. Ohm's law states that the current flowing in a circuit is directly proportional to the applied potential difference and inversely proportional to the resistance in the circuit. In other words, by doubling the voltage across the circuit, the current will also be doubled.
Good day. I'm Geffroi Recabar and I'm assigned to present the materials for this performance task for the fourth quarter. In this experiment, we are going to use FET Simulator Circuit Construction Kit DC, in which we are going to pick the lab. Given the materials here, we must follow the procedure so that we can perform the laboratory experiment right. Thank you.
To be able to find for the theoretical values of the current and the voltage, we should use Ohm's law. To come up with the amount of the voltage, we should solve for the product of the current and resistance, while for the current, we should divide voltage to the resistance. On trial 1, theoretical voltage is 12 volts, which is the product of 0.60 amperes times 20 ohms, while the theoretical current is 0.6 amperes, which is the result of 12 volts divided by 20 ohms. On trial 2, theoretical voltage is 12 volts, which is the product of 0.30 amperes times 40 ohms, while the theoretical current is 0.3 amperes, which is the result of 12 volts divided by 40 ohms. On trial 3, theoretical voltage is 12 volts, which is the product of 0.20 amperes times 60 ohms, while the theoretical current is 0.2 amperes, which is the result of 12 volts divided by 60 ohms. On trial 4, theoretical voltage is 12 volts, which is the product of 0.15 amperes times 80 ohms, while the theoretical current is 0.15 amperes, which is the result of 12 volts divided by 80 ohms. And lastly, on trial 5, theoretical voltage is 12 volts, which is the product of 0.12 amperes times 100 ohms, while the theoretical current is 0.12 amperes, which is the result of 12 volts divided by 100 ohms.
Hello, I am Christian Suplido, the one that is assigned on tables, diagram, and computations. As you can see here in our table, we assign values in our resistance in an increasing order. On the other hand, we assign a constant value to our experimental voltage, which is 12 volts. To get our experimental current, we use the Circuit Construction Kit DC FET Simulator. We utilize the wire, the battery, the switch, the resistor, the voltmeter, and the ammeter, which we will use to determine the experimental current. We assign value which we already have, which is our 20 ohm resistance and a 12 volt experimental voltage. With this, we can determine the current, which is 0.60 amperes. We repeated the same process all throughout the trials. You can see there is a difference in our experimental current as we increase the resistance. In doing the theoretical voltage, we use the formula VTH is equals to experimental current times the resistor. So 0.60 times 20, 0.30 times 40, 0.20 times 60, 0.15 times 80, and 0.12 times 100, all of which results to 12. In our theoretical current, we use the formula ITH is equals to experimental voltage divided by the resistor. So 12 divided by 20, which results to 0.6, 12 divided by 40 is 0.3, 12 divided by 60 is 0.2, 12 divided by 80 is 0.15, and 12 divided by 100, which is 0.12. That is all for the tables, diagram, and computations. Now I'll pass you to my next groupmate, which is assigned in analysis.
I'm Joules Sargado. The primary goal of this experiment is to demonstrate the theory of Ohm's law. To explain, Ohm's law can be used to measure the relationship between voltage, current, and resistance. The law's equation is commonly represented as a triangle, with the voltage on top and current and resistance on the bottom, with only a line separating between them. Proceeding to the results, the values we set for the resistance in the table are in increasing order, and we set the FET simulator at a constant value of 12 volts for value of voltage in all trials. A value that is decreasing for the experimental current came up through using the ammeter. When voltage is constant, we can now clearly see the relationship between current and resistance. The resistance value of the resistor has an effect on the current, and as the resistance value decreases, the current increases. Since the resistor and the current are indirectly proportional, the current decreases as resistance rises, while the voltage remains steady.
Thank you, Joules. As we can see from the demonstrations and explanation from Joules, is that when the value of the voltage is constant, the relationship of the resistance to the current is indirectly proportional, where one thing would increase in value while the other decreases in value. While the relationship of current to voltage is directly proportional when the value of the resistance is constant. Those were the observations that we have made. So thank you everyone for listening. Maybe we move on to our conclusion.
Good morning everyone, my name is Kris Orbina and I'm assigned on the conclusion. In conclusion, our goal is to demonstrate the theory of Ohm's law. The Ohm's law can be measured through the relationship between voltage, current, and resistance. The values that we set for the resistance in the table are in increasing order and set the value in a constant 12 volts for the value of the voltage. Thus, the value that is decreasing came out through using the ammeter. When the voltage is constant, we can determine the relationship of the current and resistance. As the resistance value decreases, the current increases, and the current decreases as resistance rises, while the voltage is constant.